hopefully more people will show up, but if not, we'll just go with the best here.
Okay.
Which is Mary. Okay. Which problems would you like to start with?
Let's start with other problems to do. Let's try 15.
Okay.
Need to write it down. There we go.
All right, 15. Looks like that. Okay, so on this number 15.
Okay.
We've got basically two factors here. We've got 3x minus 4.
Can you switch your camera? I can't see it.
Oh, okay. Pardon me.
Oh, you're good. There you go. Hi.
Okay. Hey, thank you for telling me. Yep. All right, so 3x minus 4, we've got one factor, 3x minus 4, and the other one is the square root of 2x plus 1.
Mm-hmm.
And over here, we're going to have, we're going to write 3x minus 4. I'm going to set it equal to 0.
Okay.
And then I'm going to solve to see what x is. So I'm going to add 4 to both sides. X equals 4. Then divide by 3. X then equals
4/3.
4/3. And then I'm going to do the same thing over here with just the radicand, which is the part under the radical.
Mm-hmm.
2x plus 1 equals 0. And subtract 1 from both sides. 2x equals negative 1. Divide by 2. And x equals negative 1/2.
Mm-hmm.
And then we're going to go and graph this. Make a number line here. There's negative 1/2 first to the left. And I'm going to put 0 in here just for reference, and then 4/3. Now, because it has this greater than or equal to sign, it can be equal to 0. We're going to use closed dots on those points. If it was strictly, if it didn't have a little line underneath, it was just greater than 0, then we would use open circles rather than the closed dots.
Okay.
And then we're going to make a sign array or a sign chart. And we're going to consider negative 1/2. To the left of negative 1/2, it would be negative, and then positive to the right. And then at 4/3, to the left of 4/3, negative and negative with positive to the right. As we focus on this, especially the greater than part, greater than 0 equals, what would that be? What kind of numbers are greater than 0?
Would it just be 0?
Let me put it to you this way. If I've got two numbers, let's say positive 3 and negative 3, which one of those numbers is greater than 0?
3.
Positive 3. So being greater than 0 means that the numbers are positive.
Okay.
So down here, we can say a negative times a negative is
Positive.
in this interval. Negative times positive would be negative in this interval, and positive times positive would be
Positive.
positive in this interval. So now let me think about this for just a second, because I think we might need to consider something else.
Okay.
If I put negative 1/2 in here for x, negative 1/2 times 2 would be negative 1. Is that correct?
Yes.
And negative 1 plus 1 is 0.
Yep.
The square root of 0 is 0, so that's fine.
Yep.
But if I choose a number to the left, as our sign chart would indicate here, let's say I went to negative 1 is to the left of negative 1/2. Negative 1 times 2 would be negative 2.
Okay.
Plus 1 so negative 1 times 2 would be negative 2, and negative 2 plus 1 would be negative 1. But I can't find the square root of a negative number.
Okay.
Not in the real numbers. And so so I can't go to the left of here like it would indicate that we can. So that basically cancels those solutions that would go off to the left.
Okay.
But negative 1/2 is still a solution.
Yeah.
Now 0, let me use a different color to call your attention to this. 0 is in this interval between negative 1/2 and 4/3. If I put 0 up here, I get the square root of 1, which is 1, and 0 here times 3 would be 0. 0 minus 4 is negative 4. So you'd have negative 4 times 1, which is negative 4, and negative 4 is not greater than 0. So the numbers in here, that what I just used by using 0 as an example is what's called like a test point. And just as we would indicate here, since it's negative in this interval, we nothing in between here would work. And so we go over to 4/3 and go to the right. We switch back to green. And that would be the solution. So the interval notation of this would be
4/3.
negative 1/2, because it's still the solution. Union bracket 4/3. What would I put to the right?
0.
No. Notice how the arrow goes clear off to the right? Means it's going to positive infinity. And here we use a parenthesis because the parentheses mean that it can't be equal.
No.
So this is the solution set.
Okay.
Did Mrs. Heckman, when she was making this video, did she go over any of those like that?
I don't remember. It's been a while.
Did you watch these videos?
Not yet.
Yeah, this tells you how to do the assignment. So this is what you want to do is what every day when I give you a new module to work on new lesson, there'll be a video, and it'll sometimes be made by me and sometimes be made by someone else. This one was made by Mrs. Heckman.
Oh, I was wondering who that was. Like, she sounds familiar.
In 10.4 here, we are solving one variable inequalities values.
So I'm going to skip forward.
Okay.
The nice thing is that you can skip forward if you feel like, hey, I know this part. Let me move to the parts I don't know.
Yeah.
When you have a negative out front, we do a row of negatives, which again then would flip all of my answers. Okay. Now, of course,
she's just explaining how to make the sign arrays, the sign
so that would
charts.
This to a positive, positive, negative. All right. So next, +6. Row for -6. Equals 2/3. And or equal to, guys. So this is going to be positive numbers, and we are going to include our zeros.
This
equal to.
This right here, Mary, is an
Let's make our
example
number line. We've got
similar to the one we just did.
And 2.
Oh, yeah.
-3. We have negative, positive, positive. And that only happens once. 2, we have negative, negative, positive. If we go straight down, 2 negatives make a positive. 1 negative makes a negative. And 2 positive makes a positive. All right. Now, here's what I meant by tricky, tricky. Because this is a square root, which means this also cannot have numbers less than -3, because we can't have a square root of a negative number. So actually, we are going to cross out these values because we cannot have anything under that square root that is a negative number.
Okay.
Now, look at this and we say positive. Well, our only positive value is here. So the interval I want is from 2 to infinity. Do you guys see how I did not put anything right there yet? Because it's equal to. So equal to, since we're including 0, is going to be bracket. Next page. 2 more examples, guys. Let's see if they give us any.
All right, Mary. So she went through that. The one thing she didn't consider is what about 0 in this case? And so our solution included that 0, and I think hers should have included that as well.
Yep.
Because if I put in negative 1/2 here,
Uh-huh.
if I put a negative 1/2 here for x, negative 1/2 times 2 would be negative 1.
Yeah.
Negative 1 plus 1 equals 0. And the square root of 0 is 0. Over here, I'm going to get something, whether it's positive or negative or whatever it is. When it's multiplied by 0, it would be equal to 0. And so that solution should also be included.
Okay. Yeah, I was wondering what that voice sounds like. It's like she sounds familiar. So with Mrs. Heckman. Okay.
Yep. Okay, so what other problems would you like to go through?
Let's.
Do we want to do one of the simpler ones?
Yeah, probably do like the simpler ones.
So if you look at 1, it's greater than or equal to 0. 2 is less than 0. 3 is greater than or equal to 4. Let's do number 3.
Okay.
So we can talk about what happens when we have something like that, where it's not greater than or less than 0.
Mm-hmm.
So that the thing that we have to do actually is make it so that it's greater than or equal to 0. So we're going to have x squared plus 3x. And to get 4 from the right and to the left, I'm going to subtract 4 from both sides. So I'll have minus 4 over here, which will be greater than or equal to 0.
Okay.
We then want to factor this. So we set out our parentheses, greater than or equal to 0. And we say x. What two numbers multiply to give me negative 4 that combine to give me positive 3? So I'm going to say 4 and 1. To make the 3 positive, the 4 would have to be positive. The greater value would have to be positive. And then negative on that one. So negative 1 times positive 4 is negative 4. Whereas 4 plus 1, negative 1 would be 3. So our numbers, what value makes x minus 1 equal to 0? What value of x?
X minus 1.
What number would I put in for x that would make x minus 1 equal to 0?
Would that be positive 1?
Yeah, because 1 minus 1 would be 0. So x equals 1. And then the other number, x equals, what would it be?
Negative 4.
Negative 4. Excellent. So then we're ready to do our graphing here. So we'll put negative 4 down here. And put 0 just as a point of reference, and then 1. Then we make our sign arrays. Now, because it can be equal to 4, we're going to put a closed dot at both 4 and 1. I'm sorry, negative 4 and 1. Because it can be equal at those points. Our sign array, we say at negative 4, we have negative, positive, positive. And then at 1, we'd have negative to the left of it and positive to the right of it. And then negative times negative is
Positive.
positive. Negative times positive.
Positive. Wait, no, negative.
And then positive times positive.
Positive.
Positive. And because we're dealing with greater than 0, that means that it is also positive. So our solution sets for this would be this interval here where it's positive and this one over here where it's positive. And so we can show that by shading off to the left here and shading off to the right here.
Someone named Michael Bringhurst is coming up.
Oh, excellent. So now we've got, on the left, we've got negative infinity to -4 with the union of 1 to positive infinity. And that's our solution set is both of those intervals together. Does that make sense?
Yep. He was here, but he just left.
Oh. All right. Okay, which ones do we want to go through now?
Let's do. Let's try number 9.
Okay, number 9. All right, on number 9, we've got x on the top and x plus 3 on the bottom. So we don't really have to do any factoring. The x on the top what would make that 0? Well, if x equals 0. And then the one on the bottom, x equals negative 3, right?
Yep.
And we're considering that this is going to be true when we've got greater than or equal to 0.
Mm-hmm.
Means that this would be positive.
And when the equation that's less than 0, would that be negative?
Right. If it's less than 0 or less than or equal to 0.
Okay.
So we draw out our sign arrays, or our number line. I'm going to put -3 here. I'm going to put 0 here. And to the left of -3 would be negative, and to its right, positive and positive. To the left of 0, we'd have negative and then positive. And so as we sum this up, negative is
Positive.
positive. Negative times positive would be
Negative.
negative, and positive times positive would also be
Positive.
positive. So because it can be equal to 0, we're going to use closed in dots. And then we're looking for the intervals where it's positive, and that's to the left of 3.
Mm-hmm.
So it goes off here. And then to the right of 0. And so that's what the interval looks like in terms of its graph. For the interval notation, we would write from -infinity to -3. What do I put at -3?
Bracket.
Excellent. Why?
Because it's not going. Because it's closed. Because it's not going anywhere.
It's said to be closed because it's closed at 3 because it can be equal to 3. Or I'm sorry, -3.
Okay.
So it's not like if it was a parenthesis, it could go to -3.1 or -3.01 or -3.00001, but it can't actually be at -3.
Yeah.
But this interval can be right at -3 and can be equal there because of this little equal sign down here, greater than or equal to 0.
Okay.
So then we'll go union with another bracket at 0 for the same reason,
Mm-hmm.
but this one goes off to the right or to positive infinity.
Okay.
And we always use a parenthesis at positive infinity or negative infinity because those are not numbers that you can get to.
No.
Okay. All right. What do you think?
It's really interesting to learn this type of math.
Yeah, pretty cool.
Yeah, I love math.
All right. So number 9.
This one. Do you want to try a couple more?
Yeah, I'd say let's try a couple more.
Let's 8. Yeah, sure.
Ooh. 7 too. Look at 7.
Oh, geez.
Let's look at 7. Let's do 7 first.
Okay. Minus.
Okay, so number 7. The first thing we're going to do is we're going to take x cubed minus 6x squared. Because we want one side to be equal to 0. So that 7x, we're going to subtract it. Minus 7x and minus 7x. So it's going to come over here and be minus 7x less than or equal to 0. And that less than or equal to 0 this part right here means that this thing is going to be negative. That's what less than 0 means. So what do all of these have in common? X cubed, minus 6x squared, and minus 7x.
They have x on either side.
They all have an x. So we can factor out an x. And that would give us x times x squared minus 6x minus 7. So now we can take the trinomial that we've got as a result, x squared minus 6x minus 7, and factor it. So we got x times and here I'm looking for two numbers that multiply to give me -7, that combine to give me -6. Two numbers multiply to give you 7.
1 times 7.
That's it, because it's prime, it's just 7 and 1.
Yeah.
So I'm going to write 7 here and 1. We have to decide where the signs go. So they'll multiply. So to multiply to give you -7, one has to be positive and the other one has to be negative. And then they're going to combine to give you -6.
Okay.
Which one has to be negative?
Would that be 7?
It would be the -7 and then +1. Because +1 times -7 is -7. And +1 plus -7 would be -6.
Yep.
So then now we've got our three numbers here. X equals 0. Here, X equals -1. And here, X equals
7.
And we can say, let's see, here, we take our number line. The smallest number would be -1. And then 0. And then 7. All right. Because of this, because of the equal to signs, we're going to use closed dots to represent that it can be equal to -1, can be equal to 0, and it can be equal to 7.
Okay.
And then we make our sign array, our sign charts. So to the left of -1 would be negative, and then positive to the right. At 0 as our center, we'd have negative to its left and positive to its right. 7 as our center, we'd have negative to its left in each of the intervals, and then positive to its right. So we make an account of this. 3 negatives make a
Positive. Oh, really?
Yep. Negative times negative would be negative, and then a negative times a negative would be, I'm sorry, I said that wrong. Negative times negative would be positive, and positive times negative would be negative.
Oh, okay.
And positive in the next one. Basically, when you're multiplying out signs, if you have an odd number of negatives, it's negative. If you have an even number of negatives, then it's positive.
Okay.
So that's why this interval, negative times negative, is positive. And then the next one, you only have one negative, so that's negative. And then positive times itself 3 times would be positive off here to the right. So we're looking for the negative intervals. And that would be the far left one and then the one in between 0 and 7. So we can shade off here to the right. I'm sorry, to the left.
Left, right.
And then shade in between 0 and 7. And so our interval notation, we go from -infinity to -1. It includes -1, so we use a bracket. U means union. That's combined with 0 with a bracket also to 7 also with a bracket. That's the solution.
Okay.
Okay. Was there one that you wanted to go over, Mary, did you say?
I was thinking we could go over number 13.
That's a good one because it's got the absolute value.
Yes. You know, I'm using coloring pencils to help me know what I did was right for my math.
That's a good idea.
Yeah. I ran out of lead in my pencils. I'm like, why don't I use my coloring pencils? Because that helps a lot.
Okay, here you can think of this as already being factored.
Yeah.
So we've got one factor here and one factor here.
Mm-hmm.
This is going to be similar to what we had in that other problem. So here x equals 0.
X minus 2. Well, x minus 2 will be x equals 2.
Excellent. Yep, x equals 2. And so then we draw out a number line. Put 0 and 2. Okay, so to the left of 0, we've got negative and then positive, positive. Now, because this is absolute value, I don't know if you remember what happens with absolute value. Let's see if I can jog your memory here. What's the absolute value of 2?
Would that be 4?
No, it would be 2.
Oh,
What's the absolute value of 0?
0.
What's the absolute value of negative 2?
Negative 2?
It would also be 2. Let me. The definition of absolute value is the distance of the number from 0 on a number line. So negative 2 is 2 units away from 0, and so distance is always positive.
Yeah.
Or at least non-negative, because the absolute value of 0 is 0, so that's not positive or negative, but it's not negative.
Mm-mm.
So that absolute value is always non-negative.
Okay.
And so at 2, to the left of 2, it would still be positive. This is an exception to the rule.
Okay.
So rather than going negative, negative over here, we're just going to go positive, positive. And the value at to the left of 2 would still be positive, because if I take let's say 1, well, 1 is to the left of 2, right? 1 minus 2 is negative 1, but the absolute value of negative 1 is 1.
Okay.
It's still positive. And so rather than going negative, negative, we would just go positive, positive, even to the left of 2. This is a little bit different than when we've done some of the other sign charts.
Okay.
Now, because this is greater than 0, numbers greater than 0 indicate that we're looking for positive intervals. To the left of 0 would be negative. Positive times negative would be negative.
And positive and positive would be positive.
Positive and positive times positive, also positive over here. And so basically our interval is going to start at 0. We're going to use an open circle. And we're going to go to the right. I'm going to pause here for just a second to ask myself, what happens at 2?
Will that be closed?
Well, at 2, I had 2 minus 2. Here I'd have 2 minus 2 inside the absolute value brackets.
Oh,
And 2 minus 2 is, this could also be 2.
Okay.
So outside here I have 2, and inside here I have 2 minus 2. What's 2 minus 2?
2 minus 2, that would be 0.
And 0 then times the first one, 2, still 0. Is 0 greater than 0?
0 greater than 0? No.
Yeah, so this right here, 0 greater than 0, is not, this is a false statement. So right here at 2, rather than just go on through and include that as part of the solution, we're going to put an open circle there.
Okay.
And then continue off to the right.
Okay.
And so our solution set is going to be from 0 to 2, parentheses, because it can't be equal to 2. Union on the other side, 2, also parenthesis, comma, positive infinity.
Okay.
That's what that looks like.
Okay. Okay.
Okay, let's see. What other questions might you have? We might do one more.
Let's do. Let's see. Can we try? Oh, there's a lot of things to do. Can we try 6?
Sure. Let's do 6, and then we'll leave the rest for you guys to practice on your own. If you run into problems when you're working on them and you need help, just let me know.
Okay. 0.
All right. What do you think we're going to need to do first here, Mary?
Figure out what equals to x.
Yep. How are we going to do that?
Let's see here.
What do I need to do with that x squared minus 3x plus 2?
Oh, we need to factor it.
Exactly. So we're going to leave x plus 1. It's off to the left. That's fine. Then we're going to take that part right there, and this is going to be less than 0. By the way, less than 0?
It's negative.
Good. So I have x times x, and here I have 2 and 1. Those are the only two numbers that multiply to give you 2. A positive 2, so either both numbers have to be positive or both numbers have to be negative. And since we see negative 3 in the middle,
Yeah.
we'll put negative 2 and negative 1.
Okay.
Then we can go through and say, okay, here, x plus 1 would make x equal to
Negative 1.
negative 1. Good. And x minus 1,
Positive 1.
x equals 1, and x minus 2.
Positive 2.
Excellent. So now we're going to graph these on our number line. The furthest one to the left would be negative 1. I'm going to put 0 just for reference here. And we've got 1 and 2. So then we're going to make our sign chart. Oops. To the left of negative 1, negative, then positive, positive, positive. To the left of 1, negative, negative, and then positive, positive. To the left of 2, negative, 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 and then positive to the right. And that's it. So when we go through, we're going to analyze what we've got here. 3 negatives,
That'll be negative.
we give a negative result. Good. And 2 negatives,
2 negative plus 1 is negative. Positive.
would be positive, and 1 negative, negative here
Negative.
again. And then positive, positive, positive would be positive. Then as we're looking at negative numbers as our result, less than 0 being negative, these are our intervals over which this thing would be negative. So at and also because it's less than 0, it doesn't say less than or equal to 0. We're going to use open circles at each of our points. And then this is going to go off to the left.
And would 0 be closed?
So 0 itself, I only just put that in for reference. Just because it's in between negative 1 and 1.
Okay.
So it's not open or closed. It's not part of our set because our 3 numbers are negative 1, 1, and 2.
Okay.
And then the 0 that I wrote in there was just so that we can see, oh yeah, well, in between the positives and the negatives, we've got 0.
Okay.
So our solution set then starts, we start at the left. And what's the leftmost number?
Infinity.
Negative infinity. And where does it go to?
Negative 1.
What do I write at negative 1?
The bracket.
Parenthesis.
Oh.
Why?
Because it doesn't equal to anything.
Because it doesn't equal negative 1. It can't, the negative 1 with the parenthesis by it means that this numbers go all the way up to negative 1, but do not include negative 1.
Okay.
So to the left of that would be like negative 1.1, negative 1.01, negative 1.00001, but would not actually include negative 1.
Okay.
And then we have the union with the set from 1 to 2. And those are also parentheses because they're open circles. It means that we can go up to 1 but not touch 1. So in this case, you could go to the same sort of thing, 1.1, 1.01, 1.000000001. You get really close to 1, but you can't actually be right at 1 because then it would not be less than 0 on this side.
Okay.
And that is the solution set of what that looks like. I think we got it. I think I've given you enough to work with.
Okay. Thank you, Mr. What-Ups.
Hey, thank you for coming. Glad glad you could make it.
All right.
Be safe. Stay well.
You too.
I will. Take care.
Okay. Bye.
Bye.